Hi, everyone, and welcome to the EEBA webinar and podcast series. My name is Aaron Smith, and I'm joined as always by Nancy Bakeman, and we're glad that you joined us today. We've got a really exciting session. It's always our pleasure to have Peter Barrett with Dorkin Systems on the call. He's also joined by Chris Donatelli of Donatelli Builders out of Chicago, which is just down the road from us here in Minneapolis. And we're really excited to hear about his builder experience using Rainscreen products. So with that, usual housekeeping, we've got Q&A at the bottom of the screen. Feel free to enter all of your questions in the Q&A. I think we're going to hold most of the questions and answer those toward the end. With that being said, Peter, I'll turn it over to you.
Thank you so much, Aaron. It's a pleasure to be here. I always love talking to the EEBA crowd because you're a very knowledgeable crew. Today, I am going to be presenting the technical side of the Rainscreen, and I shall be followed up by Chris Donatelli of Donatelli Builders, and I'm going to basically talk about the technical side of it. Chris will then, in turn, relate his practical experience and show you some case studies and some lovely pictures. So, without further ado, I've got a lot of stuff to get through in about 25 minutes, so let me get underway. For those of you who don't know, Dorkin has been around for around 125 years, almost 130 years now, and we were founded by two brothers, and we are still owned by the same Dorkin family. We began in paints and corrosions, and we have since moved into all sorts of different construction product envelope applications. We make water-resistant barriers, the Rainscreens, which you'll hear about today, air barriers, vapor barriers, roof underlayments, garden roof systems, foundation moisture protection, mostly well known as our famous Delta MS, and we work on both residential and commercial construction. My part of the presentation was done in conjunction with RDH Building Science Laboratories that helps ensure that you guys get good technical information from me. So Rainscreens, a builder's experience. So we'll look at ventilated Rainscreens with moisture management. Today we're going to discuss moisture management of new stucco and adhered stone assemblies compared to traditional mass walls. We'll look at common failures within stucco cladding, and we'll explore the importance of drainage and drying. We hope to explain the building science principles behind the Rainscreen strategy for rain control. We'll look at wetting and drying mechanisms, look at a couple usual details, then we'll talk about some best practices for the ventilated Rainscreen approach. So some common failures in stucco walls. In essence, the most common failure of stucco walls is water intrusion. In an ideal world, we have a perfect barrier, we get no water intrusion. In the real world, we get water moving through our cladding, whether it's stucco or stone or other claddings. We almost always get water through our cladding, and it comes in through penetration, through flashing details, and other imperfections. Here is a quick look at the average rainfall in the US. The reason I'm showing you this is to show you where Chicago is on here, because this is where Chris's case study will take place. So I just wanted to show that Chicago is a fairly moderate climate. It gets an average of 35 to 40 inches of precipitation a year. By the same token, we want to look at rain exposure and climate region. So again, Chicago turns up in the moderate range when it comes to rain exposure and cold for climate regions. So again, you'll see 20 to 40 inch of drainage plane, drainage space. So in other words, you need the drainage there in the wall. I apologize, I clicked too many times. Some key stucco failure areas in the US continue to be places like Pennsylvania, Texas, and Florida. What Chris is going to show you today happened in suburban Chicago, and I just really wanted to show you that Chicago is not a really extreme climate. It's a moderate climate, and a pretty common experience for both the US and Canada. So why do stucco assemblies fail? Well, in essence, too much water gets through it. either through cracks in the stucco, through unsealed penetrations and transitions, and there's either no or insufficient flashing. Additionally, when that water gets in, it's often blocked from coming out. In other words, there is no drainage for the system. Your system becomes a water collection device instead of actually draining water like it ought to. And that usually comes from lack of weeps or drip screens, or you haven't put the drainage in there properly, or there's lack of flashing, so the water's running where it pleases, or the adhesion of the stucco to the WRB or weep screed is weak. So adding drainage capacity behind stucco is cheaper than replacing rotting sheathing. That's probably going to be the main topic of Chris's presentation. Introducing some rain screen strategy. Well, what are the sources of moisture in enclosure walls? As I've already said by the maps, rain and snow, so precipitation. There's also water vapor. We often build in moisture, particularly if you've had that lumber lying around in the rain, and then we build the home with it, then we build that moisture into the structure. You can also get moisture from the ground, whether it moves in through the basement or comes up through capillary action. The moisture in the ground will also affect. So what are the interior moisture sources for an enclosure wall? Well, as I just said, wet building materials or water intrusion that sits in there, all of those wet materials will want to dry. When that water leaves the material, it has to go somewhere, and it usually goes into whatever cavity space it can find according to the moisture vapor pressures on it. But then it also gets moisture through the life, and that's what we call operational moisture. Humans give off a lot of moisture, transpiration. We also like our plants and pets. We clean the place, we shower, we do laundry and dishes, stuff like water pipes break, or maybe we find it too dry and we intentionally add humidification. How do we control moisture? Moisture management is really what we're talking about today, what to do with the water when it hits. Rain control has 4 fundamental Ds. Deflection, which means when it hits, we send it where we want it to go. We do that through flashing and eaves troughs. Drainage. Well, this is an object to keep the water out and send it again to a collection point where we can carry it away harmlessly from the building. Drying. As I said earlier, we know water gets in, we know things are wet, and in this case, we would like to help them dry out. So this is adding drying energy or ventilation. And then you have the durability of your building materials. In other words, don't get your moisture sensitive materials wet. We also want to control condensation. We do that through the reduction of thermal bridges. We definitely want to avoid air leakage, as air carries much more moisture than, transports much more moisture than movement by diffusion. In doing so, we also want to manage our interior RH. That helps us manage the moisture vapor pressures within the building. Concealed barriers, why do they fail? Well, the concealed barrier is the barrier that's behind your stucco. What you're seeing here is an extremely common stucco assembly. From the inside out, you have framing, followed by sheathing, in this case, most often wood-based. Then you have a water-resistive barrier system. This can be either 2 layers of a 10-minute grade D equivalent building paper, or it can be a single layer of 60-minute grade D equivalent building paper. Then there's standard lath, that could be metal or that could be fiberglass. Then comes the stucco, base coat, finish. There's also the trim accessories. We're showing a little foundation there as well. The ventilated rain screen is the most robust rain control strategy. What does the building code say? The International Residential Code says, or this was changed in 2006 to say that it requires a means of draining the water that enters the assembly to the exterior. It does not explicitly say what constitutes that drainage, and we have the same wording in 2018. So here's the actual section from the 2018. Sorry, I won't read that to you, but the spot that interests us most is right here. And this is really where a rain screen can fit in on the code, where the water resistive barrier that is applied over a wood sheathing has a water resistance equal to or greater than that of a 60-minute grade D building paper, and is separated from the stucco by an intervening substantially non-water absorbing layer or a designed drainage space. In this case, the dimple membrane or delta dry that Chris will talk about, that constitutes the substantially non-water absorbing layer, as well as the designed drainage space, so that it meets code over wood-based sheathings, as long as you use a grade D 60-minute paper, which is, by the way, pretty much any decent water resistive and air barrier. In our case, that would be Delta Vent SA or Delta Stratus. Both of those would be a grade D 60-minute equivalent. So what is a rain screen strategy? Well, we clearly want to shed it. We do that with the exterior cladding. Drained, that is space for when liquid water gets in. It may in turn drain out using our friend gravity. We want to integrate flashings and drain openings properly. In other words, shingle things to the exterior so that the water runs to the outside of the building. Overlap everything. Again, shingle downward, water runs downhill. We'd like to guide it correctly to the exterior. We do not want it to stand around. And obviously, we want to avoid holes. Holes can allow both air and liquid water to get in. So what is a rain screen cladding? Well, a rain screen cladding is a rain shedding surface integrated with flashing with a structural backup wall and drainage space. Let's quickly look at how water moves. I mentioned gravity earlier. Gravity is our friend. Gravity can help us using flashing, redirect water to the outside, which basically saves it from hanging around. We clearly design houses that way quite regularly. As you can see by the little drawing there, we generally always design a building to direct water to the outside, or we should always design it to direct water away from the building. Another big problem is capillary wicking, with the cohesion and adhesion of water and its surface tension. What that basically means is water can travel quite effectively through a small crack in any material, really. It can travel up concrete substantial distances. It can travel up wood substantial distances as well. How do we know that? Well, trees have leaves at the top and not the bottom, so we know that capillary action of the wood allows water to move up to feed the leaves. So how do you handle capillary wicking? Well, as you see in the drawing on the right, we put in a capillary break. In other words, something that is non-porous, that does not allow the water to continue to move. It also moves through pressure differentials. We get many pressures on the house. We can get, in particular, wind pressure. So on the windward side is an area of high pressure. On the leeward side becomes an area of low pressure. This is essentially the same thing that makes airplanes fly. But that has a different meaning on a house, because if you get high pressure to the windward side, the interior of our house is actually lower pressure relative to that high pressure. What does that mean? If you have a hole in your wall, well, our drawings below there show that if you put pressure on the wall and you have moisture, in essence, your building will start sucking water in those little holes. because it's high pressure on the outside, lower pressure inside. In essence, it gets sucked in. The drainage space. A drainage space obviously creates a space for liquid water to flow down. It actually doesn't take all that much space in the wall to get the drainage portion itself. As it says here, anything from 1/8 of an inch to 1/4 inch will give you drainage. What 1/8 of an inch to 1/4 inch does not give you is ventilation. So we're distinguishing here between a drainage space and a ventilation space. So with a larger gap, you also get airflow. The airflow helps moderate the moisture in the cavity. It takes moisture from the cavity to the exterior. We also have a drainage plane in our rain screen. Again, this is a little bit of a repeat of what I said earlier, but I'm going to say it anyway. Shingle downward and allow the water to flow to the exterior. Integrate with your flashings. Flashings are really any material that will act as a drainage plane and shed the water as opposed to absorb the water. An opening. This is this sounds very sensible, that if you're going to put a drainage space in there and we're going to allow water to drain down, that we would like someplace for it to go once it gets there. That would be our drainage, our drainage hole or our drain. So that drainage hole will allow liquid water to move out. It will allow fresh air to move in, and it will help promote venting and ventilation. Solar-driven moisture. In our building science side here, we're going to talk about solar-driven moisture because not everybody even believes that this exists, but it is a significant problem whenever you're using an absorptive or reservoir cladding. So the cladding itself will absorb moisture. Solar energy will both cause the moisture to evaporate, but will also push the vapor inward. This is just an example of let's say some manufactured stone that is a reservoir cladding. So how does this work? Well, if we have indoor conditions at a pretty typical, let's say 70 degrees Fahrenheit, typical interior 35 to 50 or to 65 degrees relative humidity on the inside, whereas, sorry, just got to move things here so I can see. So as the sun hits our exterior cladding, it heats it up. So if we have a stucco cladding, it can get very hot just due to the solar energy, and it can create a moisture vapor pressure greater than 16,000 pascals. But because it's cooler and drier inside, we have an interior vapor pressure of around 1,300 pascals. As this notes here, your sheathing temperature can get up to over 158 degrees Fahrenheit. So one thing we always know about moisture vapor is it moves from areas of high concentration to areas of low concentration, seeking stasis. The high moisture vapor pressure on the outside means that a lot of that water that is soaked into this wall like a sponge cannot dry to the outside. It has no choice but to move inward. Sorry, I went a little fast there. So you can just basically see on this, I guess it's a small version of a psychrometric chart, but you can basically see that solar-driven moisture does exist and can drive significant amounts of water in. Once we have moisture, how do we dry it? Well, through drainage, as I said, through some surface evaporation, but also through the wall, through diffusion and moisture vapor permeable membranes, and also through convection, which we take advantage of with the air exchange, adding ventilation that allows the warm, damp air to move up and out, bringing cooler, drier air in the bottom thereby moderating the humidity in the cavity. There's a bunch of different ways one can apply cladding. A direct cladding would be, let's say, some lumber siding that's just put directly on the WRB, or even stucco placed directly on the WRB. Vented, that means some air can get behind it. A good example of that would be vinyl siding. Or ventilated, that has both a drainage and ventilated space. As you move from left to right, incorporating a ventilated rain screen actually reduces the risk of mold and rot and improves the sustainability. So in summary, water will find its way behind the water resistant barrier. Depending on your climate and region, the stress of that or the rain load could be even higher. Most stucco failures involve cracks, penetrations, sealant joints, blocked drainage paths. And by giving water a place to go, that means that it will not accumulate in the wall. And by adding drying energy, the water that does hang up in the wall or the moisture vapor that comes off our wet material or through the other sources has a place to go. It can rise and dry out, and the system is moderated. Therefore, a drained and ventilated rain screen is the most robust way of controlling moisture in a stucco wall system. So let's quickly look at a mass building. This would be anything with large stone, limestone, even the pyramids. They have an integral moisture vapor resistance. They have a very large ability to store water that hits them without incurring any damage at all. It used to be that they would just put stucco directly on a mass wall. Probably not much of an issue, but we've changed the kind of materials that we use. We don't build with mass walls so much here anymore. We use much more moisture sensitive materials. We use drywall, we use wood, we use insulation, we use papers, whether it's on the drywall or otherwise, all of which can be adversely affected by moisture much more significantly than could a solid masonry wall. What does that mean? Well, that means that the management of moisture becomes more critical because our materials are much more sensitive. Not only that, but we've added a lot of insulation to the building. In this case, we're really referring to absorptive claddings like stucco and adhered stone, but not EIFS. So moisture in buildings with absorptive claddings. This is a fairly typical detail. You can see a vapor permeable WRB, but really the thing to notice here is that we get elevated relative humidity and moisture content in the wall cavity, and we can get condensation on the back of the drywall in the summer as the warm, moist air hits the cooled back of our interior drywall. A wet cladding will allow inward diffusion through a vapor permeable membrane. It's a really important point. Anything that's moisture vapor permeable is moisture vapor permeable both ways. There is not a way to have a material that only lets moisture pass through it one way. So if it allows moisture to come out of the building to dry, it can in turn also allow moisture to be driven back into the building by processes such as solar-driven moisture. And that can cause it to accumulate in your wood sheathing or perhaps in the cavity drywall, depending what else is in there. At the same time, we get vapor diffusion from the interior. So if you have wet cladding with moisture moving in from the outside and vapor diffusion coming in from the interior, in this particular assembly, how could we possibly dry our wet sheathing? So considerations for moisture management with highly absorptive claddings, again, stucco and manufactured stone. Poor drainage is a problem. As I said earlier, water gets in but can't get out. There are some solutions. You can put in a small gap or a drainage layer, as I said earlier. anywhere from 1/8 to 1/4 inch. Sometimes that can be achieved by the creped stucco building wraps or 2 layers of building paper. But because stucco and adhered veneers have very high moisture storage and solar driven moisture, or due to solar heating, as it says here, that can create the moisture vapor pressure and drive the vapor inwards. So heat, air, and moisture flow in the ventilated air gap. Well, first of all, with a solid impermeable product, it will deflect and drain the bulk water. A big question is often, well, if I put an impermeable product in there, am I not putting in a second vapor barrier? The answer to that is no, because this is not detailed as a continuous vapor barrier. It's extremely important to the function of a rain screen that you have ventilation at the top and at the bottom. With that ventilation, it will not act in any form as a vapor barrier in the wall system. It does, however, enable the ventilation to dry the sheathing board. It also allows any condensation or bulk water to drain out. It also will prevent the inward drive of the solar driven moisture. This is just to show you quickly what a top detail looks like. You can see that there's about a 3/8 inch gap between the flashings for ventilation. It doesn't have to be a huge gap, but you do need a gap. And similarly, at the bottom of the wall, just using a typical weep screed, there's nothing special about this. You would install your stucco the same way you do, but just in front of the material. So no additional fancy changes. You can see in this picture, it's the same weep screed you would normally use. So to summarize what I said, we use a lot of different materials. The old walls are not like the new walls. We didn't build the same way your grandfather did. New stucco walls need to be detailed in order to allow moisture that gets in to get out, to allow water that hangs in the wall to be dried. A drained and ventilated rain screen is the most robust rain control strategy for stucco and stone walls. So now that I've been through the technical part, I'll turn it over to Chris, who's going to take you through the part I'm sure you're really interested in, which is him showing. Sorry, just trying to turn off my screen sharing here. There we go. Which is him showing his real life experience. Chris is a custom builder in the greater Chicago area. Chris, I shall let you introduce yourself.
Thank you, Peter. That was very insightful. And I'd like to thank Aaron and Nancy as well for allowing me to be part of this discussion today. I'd also like to thank everybody who's taken the time to participate in this. And I really hope that the pictures that I've been able to put together provide some value for you in terms of getting a grasp on what I've experienced out in the field. I need to share my screen here. Okay, could you see that?
That looks good, Chris.
Okay, so again, my name is Chris from Donatelli Builders, and I am located here in the Chicagoland area. And to give you a brief idea of my history as it relates to my experience, I started in the business in 1986 as a carpenter, largely framing new homes and doing large-scale renovations. I heard the term Rainscreen for the first time in 2010. I'm not proud of that. It took me 24 years to learn of a concept like this, but I just want to communicate the reality that there's a lot of people in the business and they could work around things, and if they're not exposed to things like this, they won't pursue it in their building practice. So the first time I heard about it was in 2010, didn't know what it was, didn't know how to use it or how it applied to building. But that's around the same time that I really kicked off my passion for really wanting to build buildings that lasted for a long time. And Rainscreens definitely have played a role in this. And I've also been using Rainscreens on every project that I've built since 2012 for all the different wall assemblies that we've built. So with that, I'd like to actually get into what I'll call the case study, which is a project that we renovated in 2011. And the majority of the building was cladded with traditional hard coat stucco, we call it here in Chicago. And the accent material was an open joint wood siding. And this was done in 2011. To give you a little bit of perspective of the scope, I just included this before picture, little circle around that front area where you could see the before and the after. You can also see the stucco starting to go together. It's actually in progress. Some of the areas in black are where the future accents will be for the wood siding, but the gray and the white is all stucco. So when we started this project, there were already concerns in my area about different types of stucco, and I certainly was concerned with putting stucco on a building just because of some of the things that were around in terms of problems that I had seen. So in addition to what we see as the minimum requirement for code, we also installed a WRB consisting of a stucco wrap, which is promoted as something that will help drainage. And we also installed a small gap drainage mat. And I had assurance from everybody who I talked to at that time that the combination of these products was all we really needed to keep everything safe. So the wall assembly was a 2x6 studs, dense packed cellulose insulation with OSB sheathing. We then used the stucco wrap is the WRB. We used then a small gap drainage mat. And then in limited areas, we used the polystyrene foam, and that was due to some details that the architect wanted to achieve in terms of returns around some of the windows. It wasn't used everywhere, but it was used on maybe 40% of the building. There was 2 layers of felt paper installed over that by the stucco installer, and then the mesh with 5/8 stucco. So my conventional wisdom in 2011 was that a stucco wrap with a drainage mat and the 2 layers of felt was certainly going to keep us safe on this project. And that, of course, assumes that you're taking the time to detail everything properly and carefully executing everything, because none of this matters if everything's not carefully executed. So now let's fast forward 10 years and let's start taking a look at what we actually found as we started to realize that there were some problems and just made the decision to take everything off in terms of all the cladding. So this here is the north elevation, and if you could just make a note of the elevations, that will be important because I want to show some differences between what we found on the different elevations. Peter had brought up the different zones and how different characteristics are important within the different zones. Here in Chicago, we're not really known as an extreme, but we do have hot humidity, hot humid summers, and we do have cold winters that are very dry. So we do get a big fluctuation. But what I'll show you as we went around the building, I think is more telling than that and how things really get more finite than that. So this is the north elevation, which is the front. And this is what we noticed when we started to take this apart. And the north is one of the exposures that gets the least amount of sun. Both the north and the east get a lot less than the south and the west. So what I'd like to point out here is, starting with the upper left, we noticed it was pretty consistent that our corners had problems on all of the elevations. That was kind of a consistent issue. But what you could also see here is that the mildew that you could see, the wetness that you could see, it's widespread. Yes, there are some areas that are heavier than others, but if you look down to the photo on the right, you'll see that that moisture is not caused by a leak. And that piece of OSB was pretty much destroyed. And if you look to the left or the right, that's where we had the open gap rain screen, different type of rain screen, different type of WRB. And frankly, the OSB there looked like it was brand new. So just a huge difference in the way that these wall conditions performed. So now we move to the east elevation. Again, this is an elevation that doesn't get a tremendous amount of sun. And I'll also note that there's not a tremendous amount of trees around this house. So the natural movement of the sun is pretty much unblocked on most of these elevations, just as a side note. So here again, we just found pretty much the same thing that we found on the north elevation. Some of the areas, as we were taking off the stucco, the OSB seemed to be embedded into the mesh, and it would just all come off, as you could see in the upper right. So this was a real eye-opener as to what was really happening behind the walls. One other thing I'll point out here, and I think I could demonstrate it more in some of the larger photos, but you're also going to notice that this moisture, and I'll maybe go a step further and say that it was beyond moisture. I would suspect that this was actually standing water within the rain screen, but you'll notice that these galvanized nails are all rusted. And if you've ever worked with galvanized nails, you know that it's going to take a long time and a lot of exposure to water before they rust to that degree. But again, this is the second elevation. That's more of a shaded elevation. And as you can see, the damage is pretty substantial here. Now we're going to go to the south elevation. And, you know, we get quite a bit of sun here. So on the south elevation, we noticed that there were a few problem areas where water wasn't draining. And this was in a cantilever over where the second floor cantilevered over the first floor. And it's also on the corner where I mentioned before that we had some issues. But if you look at the photos to the left, for the most part, you're not seeing that widespread wetness in the wall like you saw on the previous two elevations. And I believe that this is solely due to the fact that this elevation, the south elevation, is aided in its drying with the effects of the sun. So now moving to the west, which also has a lot of sun exposure. If you look up to the right, you can see in the center of the wall, there's a bad spot. If you go to the right where that overhang is and up the corner on the right, you can see that the wall's in pretty bad shape. There is a bit of widespread damage in at the upper part of the first floor wall. But as you get into the second floor, the majority of the OSB has been unaffected, although that's not ideal for sure. And on some of the other walls, you'll see that there was very limited damage with bulk water damage. So this actually, this chart here is something that I just put together, and I just wanted to communicate by my own conclusion, nothing scientific about it, but if 100% were success in the wall, I tried to just assign a value in terms of a percentage of where I felt that these walls performed in the 4 areas that are critical to any type of water resistant barrier, which Peter had mentioned before. What I've been taught is to look for the characteristics in deflection, draining, drying, and durability. And I will say that through my projects and through this one specifically, those are all critical components when you're looking at a wall and whether it's going to be successful or not. And the north and the east, I would consider to be massive failures, where the west and the south elevations, I would consider to be substantial failures. So with what we saw in this project here, and with what I've seen in other projects, I wanted to just put together more or less in a bullet point version what I feel are the top challenges as a builder to get to the point where we could really just ensure that our walls are going to be constructed in a way where they're going to last. And when I say last, I think we live in a pretty disposable environment, and my definition of a wall that's lasting, or most things that we do in the building business, my goal is to strive for 50 years. I think that if I could get something to last for 50 years, I feel that I have done a good job with it. Anything that falls below that, that needs to be replaced for any reason, in my mind, is not really hitting the mark that I really would like to hit. So here are the top challenges as I've kind of assessed them. So number one is water resistant barriers fail. I've seen this over and over. The picture on the left, as a matter of fact, is a house that I was just driving by as the siding installers were starting to take off stucco board composite, and it was a sheet material. And I just happened to get there as they were removing it from the wall. And what you could see is that the like new characteristics of that building wrap don't exist anymore. And as a result of that, it's not doing its job. As a matter of fact, if you look down by the bottom, you'll see that there's actually been voids that have been created, which I believe is just due to the material being in constant contact with the WRB and having that area be wet and dry over and over. So it's not just stucco that this exists. This happened to be with a sheet. The picture on the right is a project that we did, and we removed cedar siding. And what we found was that there was multiple tears in the building wrap. And it was, these tears obviously weren't there when this was installed. This happened to be something that just had developed through the process of the WRB being in constant contact, again, I believe, with the lumber, being wet and drying. So the consistency of what you see here, when I took this off, I was basically able to take a piece, just rip it off the wall. And if I had a piece that was like a piece of office paper, I could just tear it up just like a piece of office paper. And if ever you've worked with the WRB, for those of you who have, you know that when it's brand new, that's not the case. I mean, they're very strong. You'd never be able to tear it with your hands. They're usually very, very strong. So the failure is a reality that we have to be aware of, because, as good as these things look on the shelf when we buy them, the environments that we're going to put them in are going to have a big impact on whether they last or not. So here's just a bigger picture of a wall. And what I think this one demonstrates, this again was horizontal cedar siding, just traditional cedar siding installed directly to the wall. And you could see the amount of staining that just existed in these common areas where the siding was installed in a shiplap pattern. So I don't really believe that there was water penetrating through the siding or getting over it. I believe that this was just basically due to that moisture moving from the interior to the exterior, and both from the exterior to the interior in times when the wall had to dry in either direction. And that's going to depend on the outside temperature, the inside temperature, and some different things like that. But you could really see the amount of water that had been sitting there over a period of time. So the second thing is to really, really choose your rain screen carefully. And what I tried to do is just assemble a couple different types of rain screens that we use. The first one being a large gap strip type rain screen. And that the photo on the left just happens to be a PVC rain screen that we've used, where it just has cross ventilation through it. So if you're installing something like a horizontal siding, whether it be cement board or cedar siding or any of the composites that are made today, we're using that type of rain screen with all of them. We're never installing anything directly against the WRB anymore. We're always allowing for that ventilation. You could also, for vertical applications, you just simply turn the strips the other way and you can accomplish the same thing. But what I really like about this is that it's impossible for wicking. It's not likely for the material that you're using to break down the WRB by making contact with it. So I think that really does a lot of things in terms of long-term protection, in addition to just simply providing a drainage plane and ventilation. The second type of rain screen is more of a permeable rain screen mesh. And this is going to have a small gap. And this is what we had used on the case study. This was rolled on all the walls over the WRB before any of the subsequent products were put on there. And our conventional wisdom at that time is that that was going to do enough to drain the wall. The third type is what I refer to as a non-permeable rain screen with a large gap. So this is going to be, in my mind, the most bulletproof and the only one that I think is something I'm comfortable using on a cement-based product like a stucco or an adhered stone or brick. So when, as I've gone through this, and trust me, it's not fun to have any project that you've ever done before where, despite the efforts that you put into it or what your intentions were, when it fails, it fails. And, that gets associated with your brand, and none of us want that. And, when people go through these types of things, it's never a good situation because it's usually a surprise to them. They're not necessarily expecting a problem with their home that's going to require a solution that costs several $100,000 to remedy. So, hopefully one of the things that what I'm providing today will help you learn from some of the things that we've experienced where, maybe you don't have to go through that hardship. So if I were going to select a rain screen for a cement-based reservoir cladding, I would insist on the following 4 items at a minimum. Number 1, that includes a large gap of at least 3/8 of an inch to prevent accumulation of water and wicking of any type. The second thing is I'd want a product that is non-compressible. Sometimes when we're installing these laths, they have a tendency to compress, and that could take away from some of the benefit of having that intended gap there. And in some cases, I don't really feel that gap even existed after the cladding was put on and everything was compressed. The third item is a non-permeable item. So when the wall dries to the outside, the moisture gets stopped at the backside of this rain screen and does not enter into the cladding. And in reverse, the same applies for protection from the solar-driven moisture, where if you've got a sprinkler that runs on a wall, or you had a heavy rain and that reservoir cladding is just filled with water, and then you get a hot sun that comes out, it's going to, I believe, drive that moisture inward. And when you have a product that is non-permeable, that moisture, as it gets driven, is going to hit that non-permeable surface and it will drain down. So this happens on both sides. The fourth thing is I want to include some type of fiberglass lath or some type of lath to accept the scratch coat, thus reducing the mechanical fasteners required. And I'll get into why I think that's important in some of the next slides. But these are basically the 4 bare minimums, I feel, for something that works in an environment where you're going to use a reservoir cladding. So the first item was the large gap rain screen. On the left, we have something that started out with 1/8 of an inch. Theory says this will work. My experience says it is likely that it may not work. And the shot I took here was one of the first areas that we started removing everything. And, you know, my eyes tell me that in theory should work. You know, there's drainage plane on the stucco wrap. There's also a drainage plane built within the siding, or I'm sorry, in the mesh rain screen. But we all saw what the walls look like. So the drawbacks to this type in my mind is that they're inconsistent in terms of the thickness. They can hold water and they can stay wet. Whereas something that is in a sheet is going to be more consistent. In other words, those pedestals are not going to be compressed. It can't hold water. It will not wick, and it will not create pressure through having water that gets trapped within a mat, and then the weight of the water creating hydrostatic pressure, or when that area fills up and then you have winds, that wind could blow, and then that water is going to go to the place that it could move to easiest, and that might be within the wall, and I believe that that's what happens a lot of times. So non-compressible. Here's a picture of one of the pieces that we took off of the stucco, where the mesh came along with it, the WRB came along with it, and at the bottom, some of the OSB came along with it. That's something that eventually this all just kind of compressed together, and I have a hard time believing that you could maintain that airflow when this is happening. The picture on the right is another installation we used, where we used the Delta Dry product, which meets that criteria. It will not get crushed, and it is stable once it's put on, as you start putting on the mesh and the subsequent coats or lath. So the next is the non-permeable part. And, you know, again, the picture on the left, this is somewhat of a repeat of what Peter had mentioned, but I absolutely believe that we saw this going on with this project and others, where there's signs that in some cases the wall is drying outward, where it's passing through the permeable building wrap, and it's passing through the rain screen, and then that moisture enters the cladding. And then there's other times where the cladding fills up with moisture and it gets driven inward, passes through the permeable WRB, and then enters into the wall cavity. So I believe it goes both directions. I think we've seen that. And the picture on the right just shows the way that any moisture that hits that surface is going to drain down the front. Here you can see that there's a bug screen at the bottom that gets lapped over, in this case, our copper tins, and that allows that dissipation of any of that moisture to just drip right down through that. So the characteristic of something that is non-permeable is very, very different from something that's permeable. And in my mind, it's very important. The next, and this one might throw some of you, especially if you've never sat down to think about it like I did the other day, including a fiberglass lath to accept the scratch coat, thus reducing the mechanical fasteners required. As I was going through this with Peter, I think both of us had a little bit of a laugh because this wall looks like it was at a shooting range for about 5 years. You know, I estimated that on a 6,000 square foot wall surface, there was 72,000 fasteners that passed through the water resistant barrier. And most water resistant barriers do not seal around those. The fasteners just pass right through. So on this 6,000 square foot surface, the first thing that typically gets nailed is the WRB itself. It has to be held on to the wall sheathing. The second thing is if there's stucco channels that get installed for expansion joints, control joints, things like that. I think in the middle of the wall up there, kind of up towards the top, you'll see 2 horizontal rows of a dark spot. And I believe that that's where the channels were. Then you have the installers that are putting on the stucco, and they're going to nail the heck out of their stucco lath. And that actually has, that is actually where I think the largest amount of the nails come from. And then you have windows. Ideally, if they're taped, that's not going to be an issue, but you know, it's still going to penetrate through the WRB. So these 2 pictures here are my best way of trying to demonstrate to you how you could save. And in this case, if we would have, on the case study, I believe we could have saved 40,000 fasteners over 6,000 square feet if we used a product that had a metal lath or a fiberglass lath attached to it independently. The one on the left is Delta Stone and Stucco, where it actually has that lath built right into it. And even on the right, that was Delta Stone and Stucco, where the installers for the stucco just simply nailed it off, but the nails were much less frequent. So again, I'm looking at a difference of about 40,000 nails just going from one type to another. And if you look at the Delta Vent SA, that is not mechanically fastened, but it's an adhered product, there's no nails required to install that. So that, in my mind, is the safest way to go with water resistant barrier. So that pretty much concludes what we saw in general. And what I'd like to now do is drill into some of the contrasts that we found on the north elevation. So if we look here, we're going to see where we had combined both stucco and open gap siding, where it was open joint siding. And if you look, you know, this was all built at the same time, and you could see, if you look at the plywood above that large window in the center, below the large window in the center, above the small window, and below the small window, you're going to see that those had a different type of WRB on it. It was actually a UV stable WRB that was different than the white one. And you'll see that even though that was exposed to water through the open joints in the cladding, it was a large gap rain screen. It was allowed to dry. And honestly, the OSB was in as good of shape as the day that it was put in. Whereas if you look at the other areas, that all had just basically come off the studs as the crews were doing the removal of the stucco. So pretty big difference. And here's just a little bit more of a close-up. Again, you can see the widespread moisture within that lower sheet of OSB. You could see the OSB on the left and on the right. It's near perfect. So big difference. The other thing that I'd like to point out about this north elevation is we had doubled up this wall, meaning that there's two layers of stud framing. So the actual wall that's insulated is a 2x6 wall behind the original building wrap. And then there was a secondary wall that was put onto the first wall. It was mechanically fastened to it, but there was a 3.5-inch airspace behind there. So there was air movement back there. And we also did not have the challenge of any of that interior moisture driving outward in this condition. And frankly, I was kind of shocked that this area had this type of damage, because one of the original concerns I had was that the dense packed cellulose insulation that we had might have slowed down air movement from the interior to the exterior and slowed down the drying process. But this wall proved me to be absolutely wrong with that. What I think happened here is that through constant saturation of the reservoir cladding, the stucco, through not having much sun exposure, I just believe that this wall just remained wet more than it was able to dry. And I think that what you're looking at here is a direct result of that water just sitting and just making its way through those, proportionate 72,000 penetrations in a small area, and just kind of driving inward as that sun heated up the wall. So if you're one of those people who's never been exposed to solar moisture, or if you maybe don't even believe that it exists, maybe if you doubt it, I wanted to show you this photo because I hope that this will get you thinking a little bit about whether you still want to maintain that belief. Here again, you could just see some close-ups, and you could just see the contrast in the way that the OSB has maintained itself. Really stark difference. So in concluding that's the end of my picture slides, but the one thing that I do hear people talking about, and I just wanted to throw this in there because I've heard people review it over and over, and I think it's just worth mentioning. I hear people asking a lot of times and focusing on, hey, what should I use on the outside? Should I use plywood or should I use OSB? I heard that OSB could turn into what some call vertical mulch, and that's true. But I will also tell you, if plywood is exposed to moisture, it's not going to last either. Arguably, it will last longer than OSB. But the real point I want to make here is that I don't really believe whether you use plywood or OSB makes too much of a difference. And the reason why I say that is because what we need to do is we need to keep either sheathing completely dry. And we need to build walls that ventilate, and we need walls to dry when that water gets behind there. And we know through experience now that water always gets behind the cladding. It's never going to be avoided with caulk. It's never going to be avoided with anything. There's always going to be some water that's going to get behind there. So we have to, create a means for drying. So all of this material costs money. If it were me and someone wanted to give me plywood, I would take the plywood over the OSB. But I think it's worth considering paying for a better level of a WRB, a better level of a Rainscreen, in lieu of maybe investing in the plywood that costs more money. That's the way I look at it. I know not everyone's going to share that belief with me, but that's just something that I've concluded as I've gone through all this, and I just wanted to share that with you. And then finally, achieving that 50-year mark takes a strong commitment, and I think that everyone that's on this call right now probably shares that commitment. And I say, take my hat off to you and say, hey, that's great that you're taking time to learn about this and absorb all the information that you possibly can. And, a lot of you will do your best in specifying materials that you believe in. A lot of you will do your best in, other means to make sure things get built. But in being out there in the field, the other part of this is it just takes constant oversight, because there's so many times that it's unavoidable that you just can't get, that person that shows up on the crew, one of the crews, and, they put nails where they don't belong, or they just do something that is really not taking you in the direction of doing something the right way. And with this photo right here, I'm just trying to show all that's involved with putting that tape on, using the right kind of tape, using the right kind of Rainscreen system, incorporating the ventilation with it. These are all things that you just can't pick up, with the lumberyard's delivery. It makes it more complicated to order the materials that you need, but I truly believe that you have to cherry pick the products and really oversee them properly to be able to get this to the point where, you don't have to worry about this stuff failing. So I hope that was helpful. I hope that provided some value, and I think that they want to take some questions if possible.
Yeah, Chris, I would just want to thank you for sharing your experience and knowledge in this area. And it's really something to see. I did a mold remediation in the stucco house myself, and learned many of those lessons the hard way. So I sure appreciate you sharing that with the audience. I think one of the questions that kept coming up is, did you see any difference where you had that continuous insulation? And did you notice anything with air leakage from the interior of the structure? I don't think so, because you showed us that cavity and the Tyvek was behind it and seemed to be in good shape. But any lessons learned there?
Can I jump in quickly, Chris?
Yeah, sure, Peter.
I wanted to point out, you showed a very nice picture earlier of that one board in between that was all covered in mold. And yes, that one. Where that air leakage, it would be much more localized,
Right.
to the hole or defect where the air was passing through.
Yeah.
This one is all across the board, which indicates it's another moisture vapor issue. That's a great question.
Yeah. No, I think even on I think it was the east side, we saw there were no pinpoint areas where you'd have an air leakage problem showing itself. It was pretty widespread across the elevation.
Yeah.
The second question, I think, was around you said about 40% of the house had continuous insulation on it. Did you see a difference in the areas with continuous insulation, or was I wrong about that number?
I noticed no difference. Again, when we detailed the house with the insulation, we use a dense pack, which, obviously is going to work much better in terms of limiting air movement compared to something like a fiberglass bat insulation. And even in areas that we took the plywood off, that insulation remained pretty much intact, and it was pretty tight within those wall cavities. So I did not actually notice that difference. And I think what some people might be driving at with that question is, the best practice with building is to actually use an outer continuous layer of insulation to prevent the condensation point being at the back of the plywood.
Right.
I've done dew point tests on other projects. We didn't do one on this, and frankly, this wasn't installed for that purpose. This was only a 1/2 inch, which I don't know if that would have been enough to really make a difference that way. But I think what's really telling about that question is not where we installed the foam, but where we didn't install it. Because, in this area here, we don't have a differential in temperature or anything like that between the front side of the sheathing and the back side of the sheathing. That back side of the sheathing should have been like an unconditioned attic that was really, really cold. And, I was not expecting this kind of damage in these areas that we built out this way. This was a bit shocking to me. And I think that this, speaks more to the moisture getting through that non-permeable rain screen.
Yeah.
Possibly even being, I believe that, if you look here, although these are plastic cap nails, but if we go back and we look at this picture of this wall, again, those galvanized nails are not going to rust unless there's constant water up against them.
Right.
And, my suspicion is that, we did something with a good intention, but it didn't have the result that we expected. We used a rain screen, we used a, drainage plane type mat, because at the time, that's what I believe would really do the trick. But I don't have that same belief anymore. I would never, frankly, I would never use one again with that type of product. So, this really opened my eyes to a lot of things that I wasn't necessarily thinking about before. And it really helped me ask the question, why is this happening here and not there? Or, what's going on here? So I'm hoping that these photos really demonstrate to everyone and get them to think about it a little bit more, knowing about the way that the walls were constructed and knowing what we did to formulate some of their own questions and their own feelings about what they're looking at here.
Yeah. One question I think we all want to know is, Peter, does Dorkin Systems have architectural details available on your website that we should be including in our plans to detail this out correctly for future projects? And if so, can you maybe chat that in the function, and we'll put that in the resources section at EEBA?
We'll do that immediately.
Perfect. So watch for the chat. I know I've looked at your details, Peter. It's best practice to follow. And I love, we had a comment, not a question, come in, but doing proper rain screening is the best insurance you can buy as a builder. Right, Chris?
Well, what I'd add to that is, I mentioned this to Peter when we were talking, and I said that, in building, sometimes I find foundations that, have twice as much steel as maybe I think they need, or, the wall has been thickened up for whatever reason. And, just simply oversizing something just to be safe when there's that type of cost involved with it, it is not really what I think is ideal. Sometimes I think that's the easy way out, just saying, okay, we'll just, if it needs to support 10 pounds, we're gonna, design it to support 50 pounds, okay? And the customer will pay for that, and the customer will be happy to pay for it, because they're getting a strong building. I've questioned whether that really is the right thing, because I've seen projects that just couldn't be built because they were designed with too many things that just made them too expensive.
Right.
That being said, this is something that you can't go back on. And, if we want to talk numbers, you're looking at 40 grand just to take off what was here, haul it away and patch the siding and put basically, an inexpensive WRB on to keep it dry and just let the building sit and dry out for a while. Now, the cladding to replace it is more in the $300,000 to $400,000 range, but that's going to be, they're looking at very, very high-end claddings. So that's not the norm, but I could say that my feeling about the way I'm approaching, moisture management with my problems is I never, ever, ever want to experience another problem with that. And again, if I have to find ways to look at being able to afford incorporate the best products within the assembly, I'll look for other places to take it. But short of a large gap ventilated rain screen in some of these situations, I just, at this point, you can't convince me that it's not going to work, that it's going to work.
Yeah. Oh, again, great advice. Peter, I don't know if you want to take that question we just had from Michael Lynn come in.
Working on it.
Yeah. So you'll type an answer there.
Yes.
Great. I'll do a quick wrap up, but again, Chris and Peter, thank you so much for coming. We had an incredible turnout today, and And Chris, again, hats off to you for sharing, really opening your heart up and sharing your great knowledge that you've learned over the years. And we greatly appreciate that. We will have this recording posted up at EEBA. We'll have it on Spotify for podcast. Peter, I think we'll ask for a PDF. We had a lot of people ask for the PDF for the presentation, so we can send that out to the attendees and post it up at EEBA as well. So with that, I want to thank you both so much for joining us today.
Thank you.
Thank you very much. I always love presenting to the EEBA crowd because they're very knowledgeable and enthusiastic. Thank you so much for the opportunity.
We love it, Peter.
Thank you.
One final thing, if anybody wants to reach out or has any questions, or if I could forward any information, email address is chris@donatellibuilders.com. If I see something come up, I'll do my best to respond.
You're the best, Chris. Thanks so much for sharing.
My email's in the chat.
Awesome.
Thank you.
Thank
Thanks,
you.
everybody.